Hi all, today's topic is sequence and series, unit 5. So in this, these are the topics to be covered in the unit 5. It's nothing but sequences, series and comparison test, D'Albert ratio test and Rabi's test and logarithmic test and Cauchy root test and Leibniz test and absolute and conditional convergence. These are the topics in my video. You can check in my playlist. So now the topic is sequence, and sequence is nothing but an ordered set of a real number a1 etc. an is called as a sequences. We can write it in a braces as an or open bracket an. So it is called as a sequence. So there are some types of sequences. Finite sequence, from the name itself everyone can understand. It's finite sequence means finite number of the terms means it is called as a finite sequence. Infinite sequence means it is not a finite means it is an infinite sequence. Real sequence, a sequence whose range is a subset of R means it's called as a real sequence. Limit of a sequence, how we have to write for a sequence in the form of limit means a sequence is 10 to a limit L. For every epsilon greater than 0, a value n of n can be found such that, so an minus L is less than epsilon means for every n greater than or equal to n, then we say that it's the limit of the sequence. Or shortcut, we can say it, limit n tending to infinity, an is nothing but L. Okay, depending upon this L only, we can say it is a convergent or divergent. When you have a finite means, finite limit means it's called as a convergent. When you have a infinity means it's a divergent. For example, see here the convergent sequence. So, if the sequence an have a finite number. So in the L you have finite number, and the answer you get any finite number 2, 3 like that, any number you get, it's called as a convergent sequence. When you have an infinity answer you have means it's a divergent sequence. So next type is nothing but bounded sequence. A sequence an is said to be a bounded. When we say it is a bounded means if there exists a number k such that an is less than k for every n, then we say that it is a bounded sequence. The last type is nothing but monotonic sequence. So when we say it is a monotonic sequence means a sequence is said to be a monotonic sequence means if it increase steadily or decrease steadily accordingly if the conditions are satisfied. For example, this is our condition. Is nothing but an plus 1 is greater than or equal to an, or an plus 1 is less than or equal to an for every n. Okay, for all the value of n. Both increasing and decreasing sequences are called as a both we say it is a monotonic sequence. For example, this is 1, 4, 7, 10. It's a increasing. 1, 1 by 2, 1 by 3, it's a decreasing. So both it is a monotonic sequence. This is the example for a monotonic. This is some definition. A sequence, when it is a monotonic, unbounded, both the condition if it is satisfied means, then we say that it is a convergence. It can be asked in the MCQ also. So first problem. So what is the first problem means? So how to write the general term of the following sequence? So some 3 examples I have taken. So some terms are given. So we have to write the general term for the given. So general term for the sequences. Okay. So general term for a sequences, it will be written with the symbol UN. In some book AN it will be written. So it's not wrong. Any symbol. Okay. UN. So okay, nth term. So we are writing UN. Okay. So UN can be written. So see, check here 1 by 2. So how it can be written 1 by 2 first element. Okay. So it is in the comma. So 1 by 2 the whole squared. Second element 1 by 2 the whole cube, etc. No, it goes on 1 by 2 the whole 4, etc. It goes. Okay, so now general term u, how can I write? It's nothing but 1 by 2 the whole power n, or I can write it 1 by 2 the 1 by 2 power n. So both are same only. So it is a general term for the first case. The second case AB 1 by 2 the whole square, 2 by 3 the whole square, 3 by 4 the whole square, and 4 by 5 the whole square. So now how can I write the general term? UN is nothing but, you check 1, 2, 3, 4. Okay, so 1, 2, 3, 4 is nothing but 1, comma 2, comma 3, comma 4 is nothing but n. Okay, So n in the numerator, denominator 2, 3, 4, 5. So it starts from 2 only. So 1 is not there. So n plus 1. So n plus 1. So whole squared is commonly for every element. So this is the way for writing the general term un. Okay. Third case. So now when I write it for this. So now 2 square, 3 square, 4 square. Normally start with 2 means it is n plus 1. Now we have written 2, 3, 4, 5 means it is n plus 1. Same way. So n plus 1 the whole square in the numerator. Denominator 2 factorial, 3 factorial, 4 factorial, etc. So from a 2 it start means it's n plus 1 factorial. So n plus 1 factorial. So completed. This is the way for writing a general term of the sequence. They may ask in the MCQ also like this. So the second question, prove that the sequence is a convergent. So convergent means now only I have taken. Convergent means we have to prove whether it is a bounded, then convergent condition also you have to check. So the given condition bounded, first I have to check it. For that, the given question, I will take it as un. Un is nothing but n squared divided by n squared plus 1. So now un plus 1 term I will write it. So un plus 1 term when I write it, n instead of n, okay, so it is nothing but n plus 1 the whole square divided by n plus 1 the whole square plus 1. Okay, now I have to subtract it. This you can expand it or subtract it. So now un plus 1 minus un term. So both subtraction I am going to do. So the first term as it is un plus 1 is nothing but the whole square divided by n plus 1 the whole square plus 1 minus of n square divided by n squared plus 1. Take a LCM. So we need to take a LCM. LCM both the term only I have to take it. N plus 1 the whole square plus 1 into n square plus 1. We take an LCM. Now multiply this into this. So when I multiply it, you multiply and check n squared plus 1 into n plus 1 the whole squared minus n squared into n plus 1 the whole squared plus 1. So multiply it in the numerator. So it's nothing but the whole squared is n squared plus 2n plus 1. Already outside we have n squared plus 1. So it is nothing but n power 4 plus 2n cube plus n squared plus n squared plus 2n plus 1. Okay, minus of same way when I multiply it n squared outside. So n squared plus 2n plus 1 plus 1. So it's plus 2 I will write it. Okay. So plus 2 if I write it. Now multiply and check minus n power 4 minus 2n cube minus 2n squared. Okay, now n power 4 get cancelled. 2n cube get cancelled. This get cancelled. So answer will be 2n plus 1 divided by the denominator term. Okay, denominator as it is. Okay, denominator as it is. Okay. So now we have to check whether it is less than 0 means yes. So n equal to 1, 2 you apply and check it's a less than 0 only. So it's less than 0 for every n, for all n. So what is the meaning of this? un plus 1 is less than un. So for all n. Okay, it is a monotonic and bounded. Because it is a, if this condition satisfied means now only we have learned the definition for monotonic sequence. It's a monotonic sequence and it is also bounded, because if it is less than 0 means it's bounded, unbounded. Now only we have to check whether it is convergence. Okay, so convergence, how we can check it means limit n tending to infinity un an or un. So starting I have taken un, so same un I will take. So limit n tending to infinity, so n squared divided by n squared plus 1. Okay, when you have it like this, what you have to do, it means, so now n squared, before applying directly you should not apply a limit infinity you should not apply it. What is the rule before applying n tending to infinity means, take in the numerator common term and in the denominator also take the common term and make it as 1 by this. So that this way you have to write it. So answer is 1. So finite element you have means, okay, 1 by 1, it's 1 only. So finite element means it is convergent. Already from by this definition itself it is convergent, but we have to check, cross check the limit also. It is a convergent. So it is completed. Monotonic and bounded means it is already convergent. Same, but you have to check the limit and you have to do it. So it is one finite element we are getting. So it is also convergent.